Hey everybody, welcome back. We're going to continue on with some problem solving using dimensional analysis. So before, what we used to do is we just solve problems with just one conversion or fraction. This time we'll use multiple conversions and fractions, but basically it's the same technique as we were doing before. So let's take our first problem, which will be number 6. And it reads, how many kilograms in 1,898 milligrams? So we have 1,898 milligrams, and we're going to convert this to kilograms. So immediately, I don't really know a conversion between milligrams and kilograms. However, I think I can convert milligrams to grams because I know that conversion, and then grams to kilograms. So the strategy here will be milligrams to grams, and then grams to kilograms. So what we need to do is remember what those conversions are. And so if you have 1 milligram, that is equal to 1 times 10 to the negative 3 grams. And if you have, if you're trying to convert grams to kilograms, then if you have 1 kilogram, that is equal to 1,000 grams. Okay, so one of the things I'm going to do right now is just quickly set up the fractions, and so hopefully you will be able to do this in your mind. But one fraction is 1 milligram over 1 times 10 to the negative 3 grams. We'll call that fraction A. Another fraction is 1 times 10 to the negative 3 grams over 1 milligram. And for the kilograms to 1,000 grams, 1 kilogram over 1,000 grams, or 1,000 grams over 1 kilogram. So we'll call this fraction C and fraction D. Okay, so if we're going to convert milligrams to grams, what we want is the milligrams here in the numerator to cancel out with milligrams here in the denominator of the fraction you choose. And so the fraction to do that appears to be fraction B. So it's times 1 10 to the negative 3, 1 times 10 to the negative 3 grams over milligrams. And so at this point, milligrams cancel. We have an answer in grams. And so to convert grams to kilograms, again, we need to get this grams in the numerator here to cancel out with grams in the denominator of the fraction you're going to choose. And so it looks like you want to use fraction C. So it times 1 kilogram over 1,000 grams. And so grams cancel out. You get an answer in kilograms. So how do you handle the math? So you multiply all the numerators together, and then when you go down to the denominator, you divide by the numbers in the denominators. So you have 1898 times 1 exponent 3, and then divided by 1,000, and I get 0.001898 kilograms. Okay, so one thing I have to do is make sure that this answer is rounded off to the correct number of significant figures. So 1898 has 4 significant figures. This fraction here should have an infinite number of significant figures because each of these numbers, 1 times 10 to the negative 3 and 1, are exact numbers. Same thing here, both the 1 and the 1,000 in this fraction are exact numbers, and so should have an infinite number of significant figures. So the answer will have as few significant figures as the number with the least. The least is 4 significant figures, so we want to round this to 4 significant figures, and it's already apparently there. But what we can do is we can convert this to scientific notation. So 1, 2, 3. So this is also equal to 1.898 times 10 to the negative 3 kilograms. Okay, let's move on to the next problem. Okay, so how many millimeters in 1.402 inches? So we're starting out with 1.402 inches, and this time we're going to get it into millimeters. Okay, so again, I don't really know of a good conversion for inches to millimeters. However, I do know a conversion from inches to centimeter. And then you may know of a conversion from centimeters to millimeters, and you're welcome to use it, but I'll just use the ones that you're sort of having to memorize. So I'm going to convert centimeters to meters, and then meters to millimeters. And so let's quickly write out those conversions. So 1 inch is equal to 2.54 centimeters. And then 1 centimeter is equal to 1 times 10 to the negative 2 meters. And 1 millimeter is equal to 1 times 10 to the negative 3 meters. Okay, so let's go ahead and try to solve the problem. So we have 1.402 inches, and so the fraction I would want to use here is 2.54 centimeters over 1 inch. And so inches cancel, we get an answer in centimeters. Next, we want to convert centimeters to meters. So here we have 1 times 10 to the negative 2 meters over 1 centimeter. Centimeters cancel, we have an answer in meters. And then finally we have to get meters to millimeters. So I guess it would be times, let's see, it'd be 1 millimeter over 1 times 10 to the negative 3 meters. Okay, so let's go ahead and see what the number is. So again, I want to multiply all the numbers in the numerators, and then when I go down to the denominators, I start dividing. So it'll be 1.402 times 2.54 times 1 times 10 to the negative 2 divided by 1 times 10 to the negative 3. Let's see what I get. Okay, so the number I get is 35.6108 on my calculator. So what I have to do is round this to the correct number of significant figures. And so let's see what that would be. So we have 4 significant figures here. Now with this fraction, 2.54 centimeters per inch, one thing I hope you remember is that 2.54 centimeters is actually an exact number, and same with 1 inches here. So those are exact numbers. So they have infinite number of significant figures. Here, these will also be exact numbers. These will also be exact numbers. And so this number here is the limiting number in terms of significant figures. So we have to round this answer to 4 significant figures. So I get 35.61 millimeters as the answer. Okay, let's move on. Okay, a gas can holds 5 gallons. Express this in cm cubed. Okay, this looks like it's going to be a pain. So we have 5.0 gallons, and we need to get this into centimeters cubed. Okay, so this is a little bit tricky because I definitely don't immediately remember a conversion from gallons to centimeters cubed. However, I kind of vaguely remember we might be able to convert gallons to quarts. And then once we get quarts, we convert that to liters, and then liters to milliliters. And you might remember from an earlier talk that whenever you have 1 milliliter, that is also equal to 1 cm cubed. So that will probably work. So we can take gallons and convert this to quarts, which we can convert to liters, which we can convert to milliliters, which we can convert to centimeters cubed. So that is a lot of conversions. Okay, so how many quarts in a gallon? So there are 4 quarts in 1 gallon. So quarts to liters, so 1 liter, I'm hoping you remember, has 1.06 quarts. Liters to milliliters, so 1 milliliter is equal to 1 times 10 to the negative 3 liters. And then I'm hoping you kind of remember, this is an important one to know, that 1 milliliter is always equal to 1 cm cubed. Okay, so let's go ahead and throw them into this problem. So we have times 4 quarts over 1 gallon times, and the gallons cancel out here, and then times 1 liter over 1.06 quarts. Quarts cancel, leaving answer in liters, times 1 milliliter over 1 times 10 to the negative 3 liters. Liters cancel, leaving answer in mils. And finally convert mils to centimeters cubed. So times 1 centimeters cubed over 1 milliliter. And the milliliters cancel, leaving an answer in centimeters cubed. So I'm going to multiply 5 times 4 divided by 1.06 divided by 1 exponent 3. Let's see what we get. Okay, so the number I get is 1,000 or 18,000 867.92453. So obviously that's too many significant figures. So we have to round this to the correct number of significant figures. So we have two significant figures here, here with this fraction here. These look like exact numbers, so this should have infinite number of significant figures. 1 liter, 1.06 quarts. The 1.06 quarts, as I recall, is estimated. So this does not have an infinite number of significant figures. This only has 3 significant figures. This fraction, infinite number of significant figures for both numbers. This fraction, the same. Therefore, we have 2 significant figures here, 3 here. We're going to limit the answer to 2 significant figures. So the answer should be 19,000 cm cubed. But we probably want to write this in scientific notation, so it would be 1.9 times 10 to the 4 cm cubed is the answer. Okay, let's move on. Next problem is a little trickier. How much time in minutes will it take a runner to run 10 kilometers at 7.5 miles per hour? Okay, I think the problem with this particular problem is that you have, rather than one piece of numerical information, we have 2 pieces of numerical information. And so it may be a little confusing as to how to start this problem. So what I'm going to do is I'm just going to throw up the information that we have and talk about it, and maybe something will become a little bit more clear in a second. So we have 10.0 kilometers, and then we have this runner running at 7.5 miles per hour. So I'm going to write 7.5 miles per hour like this. Okay. So one thing that I can sort of see right now is that if we have 7.5 miles per hour, I'm going to write that out in a slightly different way, which is exactly the same. So it would be 7.5 miles. If you see a per hour here, just imagine there is a 1 there, and so over 1 hour. And so what you can see is that basically this rate is a fraction. And if you have this fraction here, that means we really have a conversion that can be used in this problem. So what this basically is saying is that basically we have a situation where we know that 7.5 miles will be equal to 1 hour in this problem. And so what you could do is write the reverse fraction if you wanted to. You could write 1 hour over 7.5 miles. So this gives us a little bit more information to solve the problem. So what it suggests to me is we want to start out maybe with this number, 10 kilometers, and then eventually use this 7.5 miles is equal to 1 hour as a conversion to get to the answer. So let's go ahead and take that approach. Okay, so we have 10.0 kilometers, and we want to know how much time in minutes this is going to take if the runner is running at 7.5 miles per hour. So we're going to take kilometers. And so again, the conversion is 7.5 miles per hour. So maybe the best thing to do first is to convert kilometers to miles. And then once we have miles, then we can use 7.5 miles per hour to convert that to hours. And then we can convert hours to minutes. Okay, so let's see, I have 1 mile is equal to 1.609 kilometers. And again, we have 7.5 miles per hour, so 7.5 miles is equal to 1 hour. And then we have 60 minutes in an hour, so 60 minutes is equal to 1 hour. Okay, so let's go ahead and throw in the fractions. So I have 1 times 1 mile over 1.609 kilometers. And so kilometers cancel, get an answer in miles. And then we have times 1 hour over 7.5 miles. Miles cancel, get an answer in hours. And then we get 60 minutes per hour. Hours cancel. We should get an answer in minutes. So I'm going to take 10 times 60 divided by 1.609 divided by 7.5. And so I get, the number I get is 49.9 0.72032, blah, 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 blah. Okay, so we have to round this to the correct number of significant figures. Let's see if we can figure out what that number might be. So with 10.0 kilometers, that is 3 significant figures. 1.609 kilometers, that is an estimate, so that's 4 significant figures. 1 in the 1 mile is infinite number of significant figures because 1 is an exact number. Here in this fraction, the 1 hour, 1's going to be the exact number. 7.5, we're going to assume it's an estimate. So if it's an estimate, this would limit this to 2 significant figures. And then with the last fraction, 60 minutes per hour, we'll assume, well, we know that they're exactly 60 minutes in an hour. So these must be exact numbers, and therefore they have infinite significant figures. So we have 3 significant figures here, 4 here, 2 here. So we have to round this to 2 significant figures. So the answer is going to be 50. I need to put a decimal here to indicate that that 0 is significant. Or another way you can write the answer is 5.0 times 10 to the 1 minutes. Okay, let's go on to the last problem. Yay! Okay, so now we're on problem 10. And so in Death Valley, California, high heat and low humidity in the summer requires visitors to consume about 1 liter of water for every 2 miles traveled on foot. How many liters of water are required for a person to walk 15 kilometers in Death Valley? Okay, so again, we sort of have 2 pieces of information. We have 15 kilometers, but also it looks to me like we may have a conversion in this problem, although it may not be so immediately obvious from the writing, but it's definitely there. In that this individual or individuals will consume 1 liter of water for every 2 miles walked. So that'll be, a piece of information would be 1 liter for every 2 miles walked. Okay. So that could be useful as a conversion. So let's go ahead and try to use that as a conversion to get the answer to this problem. So we're starting out with 15 kilometers, and the answer has to be in liters. And so here we go. So we have to get kilometers, it looks like, first into miles. And then once we have it in miles, we can use this conversion of 1 liter per 2 miles to figure out how many liters will be consumed. So we're going to go from here kilometers to miles, and so I'm just going to go ahead and throw up that information up here right now. So we have 1 mile is over 1.609 kilometers. So the kilometers cancel out, leaving an answer in miles. And then what we're going to do is put in the final conversion. We want to convert miles to liter, but we know from the problem we do have a conversion of 1 liter of water is consumed for every 2 miles walked. So it's times 1 liter over 2 miles. And so miles cancel. We get an answer in liters. Let's see what that number is. So it's 15 divided by 1.609 divided by 2. So the thing that number we get on our calculator is 4.661280. So it's obviously this very long number on the calculator. And so we have to round that to the correct number of significant figures. And so let's see if we can figure out what that would be. So we have 2 significant figures here. We have 4 here. Now this is interesting. We have a conversion here. Now note the problem. It says that we consume about 1 liter of water for every 2 miles. And so I would say that both of these numbers are estimated. So 1 liter is 1 significant figure. It's not infinite. 2 miles is 1 significant figure. It's not infinite. So both of these have 1 significant figure. So in my opinion, we have to round this, the answer here, to 1 significant figure. So it should be rounded to 5 liters. Okay, thanks for watching that. We will continue on in a bit.